we know it is based on carbon, and there's a reason that scientists think that it's the likeliest candidate for alien organisms as well. Carbon is the main element in organic compounds here on Earth, and no life could exist if it weren't for carbon's unique abilities. Carbon is able to form stable bonds with other elements, including itself. In fact, it's able to form more compounds than any other element known, with nearly 10 million carbon-based compounds found in living creatures here on Earth. Carbon is the building block of carbohydrates, lipids, proteins, and nucleic acids, all of which are essential to life. If there exists an element that can form the basis for life elsewhere, there are a few conditions that it has to meet. Carbon is considered the king of the elements because of its enormous versatility in forming compounds. If alien life forms are to be based on another element, that element will have to form stable bonds with a variety of different elements. All elements have electrons orbiting their nucleus, and bonding occurs when they share that electron with another element. This element would also need to be abundant enough in the universe so that it's not completely out of the ordinary for it to be found on a random planet. In addition, it should be able to recycle itself in some way, the same way carbon does in the carbon cycle on Earth. Living organisms need a way to expel excesses of that element back into the environment. The best alternative to carbon appears to be silicon. Scientists mainly think this because it's extremely similar to carbon. Carbon has 4 electrons in its outermost shell, and elements tend to bond so that each atom has 8 electrons. This makes carbon the perfect pair-up partner, ideal for covalent bonds in which it shares 4 of its own electrons with other atoms, while they share 4 of their electrons with it. Silicon also has 4 electrons, and like carbon is abundant in the universe. Among the top 10 most abundant elements in the universe, and 135 times more prevalent on Earth than carbon. Silicon can also bond to oxygen and form long chains with itself, much as carbon does. For these reasons, silicon seems to be the most likely candidate for non-carbon life. But why then isn't life on our planet silicon-based? Well, despite the similarities between silicon and carbon, silicon does have some downfalls. While silicon does have 4 electrons, these reside in its 3rd orbital and not its 2nd as with carbon, which basically means that it requires more electrons to be satisfied, thus tending to form weaker bonds. Carbon's bonds are so strong that when it pairs with other carbon atoms, it can become diamond, the hardest known material on Earth. Silicon also acts differently when bonded to oxygen, an essential element to many life forms. Carbon becomes carbon dioxide, a gas that is easily expelled by living beings and recycled into the atmosphere. Silicon, however, becomes quartz, which is a solid and forms sand. Organic beings would be hard-pressed to expel sand from their system easily, or indeed any solid. But one of the main reasons that we consider life forms based on other elements to be improbable is just the fact that carbon-based life is all we're familiar with. Astrobiologists look for signs of carbon as a potential sign of alien life because every life form that we know about comes from Earth, and every life form on Earth is built from carbon. Scientists can look at the reasons why this is the case, but that doesn't mean that alternatives are impossible. When we evaluate the likelihood of life on other planets, we look to see if they have similar conditions to Earth. But planets that are far hotter than our own would actually give silicon the advantage in forming life, as it can withstand far higher temperatures than carbon. Scientists didn't think that life could survive in such harsh conditions until they discovered extremophiles that thrive in the volcanic vents at the bottom of the ocean, with temperatures of around 249 degrees Fahrenheit. Scientists too assumed that planets have to be in the so-called Goldilocks or habitable zone around their star to have liquid water and the temperatures associated with life, but that notion too was thrown into question with the discovery of probable subsurface oceans inside moons like Europa and Enceladus, and Titan's hydrocarbon lakes. So when considering alternative forms of life, scientists have to be open-minded and imaginative. Some researchers have even gone so far as to consider the possibility that dark matter is a form of alien life. Sure, non-carbon life might be really weird compared to what we're used to, but there are a variety of other elements that could spawn life in the right conditions, and we can see some examples of this on Earth. Take arsenic, for example. Arsenic is poisonous to most life, but some marine algae on our own planet incorporate arsenic into complex organic molecules, like arsenous sugars and arsenobutane. Other small life forms use arsenic to generate energy and to assist in growth. Sulfur, too, is capable of forming very long chains of molecules similar to carbon, and some bacteria survive off sulfur rather than oxygen by transforming it into hydrogen sulfide. Even phosphorus is a possible alternative, as it too can form long chains with itself, and when combined with nitrogen, another common element in the universe, it can form a wide range of possible molecules. Phosphorus is already a very important element that's essential to life on Earth, so it could be essential to life forms elsewhere as well. There's even a case for chlorine and nitrogen. Because these ideas are so foreign to us, there's a concern that researchers might miss potential signs of life even if they were staring them right in the face. One experiment asked participants to look for signs of life on Mars. While the subjects were busy studying photos of terrestrial surfaces, a majority failed to see a little waving gorilla in one of the pictures. The purpose of the experiment was to show that humans develop tunnel vision when tied up in their own biases and will often miss blatant signs if they're not actively looking for them. Our fixation on carbon may prevent us from recognizing alternative forms, so we have to be open to new possibilities. Assuming otherwise means we might very well miss them. And that's the case for non-carbon life.